So I decided to up the scale of the lab a little bit. So that's the mass. Instead of the mass that you're supposed to get, I did this instead. This is about 20 millimoles of material. So everything will get scaled according to that, and then you can see like the volumes as I measure them out. The cyclohexanone is easy to measure in the balance, but the pyrrolidine and the acetic anhydride, I'm just going to do those by volume. So this is the pyrrolidine. I thought I'd open it up on camera. I already added the catalyst on a stir bar. You notice it's kind of cloudy. Oh, sorry. So I took the amount that I'm supposed to get and divided that by 3. And then I set it on this pipette, so I'll do 3 shots of this in. And this stuff's pretty nasty. It smells really bad. Now I can put the lid back on. Doesn't really look remarkably different, but we'll distill that out now. So just real quickly, set up the apparatus for the distillation. I'm going to add a second condenser column on here. And then I have to change the reaction vessel because when I scaled it up, I failed to take into account that the volume would be so much larger. So I need to set this up for a long reflux. And I figured it'd be safer just to add a secondary column to the top, and I'll run some cooling water through that as well. Alright, so it's all set to go. There's a little bit of ice in there, so you can see that. It's pumping, and it's pretty cool. The hot plate's on pretty high, but just like any reflux, we're just heating it until it begins to boil, and we begin to see some refluxing going on. So I'll go ahead and lower that, and then once it starts, we'll start a timer for 30 minutes. If anything interesting happens, of course, I'll come back and show that video. So I started my 30-minute timer. It took about 10 minutes to get to this point. I had the hot plate on already. So you can see the boiling going down here, and then you can see right here. I don't know, maybe you can't see right here. That right at the bottom of the screen. That's the refluxing. So we know that it's boiling on the inside, and that you can actually see it's kind of crawling its way up. That's called the reflux ring. You really only see that if it's clean glassware, to be honest. So I clean this pretty good. And I'll turn down the temperature just a little bit. It might be a little hot, or I'll raise up the apparatus off the aluminum block a little bit if it gets too hot. It's going up to the point where the cold water's coming in. So if it goes beyond that point, I'll move it up. So 30 minutes, actually a little more than 30 minutes has passed. And this is what it looks like. Pretty much like it started. It's a little bit yellow, but that's okay. So now what I'm going to do is raise it up off the heat. And when it's cool enough, I will disassemble and then reattach a distillation apparatus to a simple distillation. We'll distill off the water. I'm going to leave the hot plate on so I don't have to heat it up again. I know this is the temperature I need because I'm getting distillation from it. So all I need to do now is disassemble the apparatus once it cools down. So I've got the process set up here. So I have a thermometer. I've marked the temperature at about 110. Now, what should be happening in this reaction vessel, right, is the formation of the enamine. It's a yellowish color, if I remember right, and so this kind of is starting to look okay already. But what we're going to do is we're going to distill out the toluene from this mixture. Now, toluene has a boiling point of 110 degrees, But the mixture of water and toluene forms a stable, what's called azeotrope. And the boiling point of the azeotrope is actually only 85 degrees or so. Might be a little lower than that, might be 80. But anyways, what'll happen is that azeotrope will boil out, it'll co-distill, so it's a co-distillation. And so I should see a temperature at the thermometer during the process, which is the azeotrope's boiling point. That'll distill off and then it'll come down here. And if you remember for the other co-distillations that we've done in the past, you would expect to see a mixture forming, or a separation of the mixture happening down in the round bottom flask. And that'll be the toluene and water separating from each other at the lower temperature. Now, how do you know when this experiment is done? Well, what's going to happen is eventually that temperature will shoot up to 110. At that point, you're only boiling off toluene, and all the water should have been removed. The water is the byproduct of the reaction, and so I'll be having you write that up as we go along for this experiment. Well, it looks like we're starting to distill off solvent. I did crank the temperature up a little bit. You can definitely see some action going on in here, that the steam has risen to the top. I don't usually, by the way, clip this. I usually just leave it, but it doesn't really matter. And there's a little bit of liquid that's come out. If you look down in here in the round bottom flask, you'll see liquid starting to come out. So I have ice in the water, by the way, so it's keeping it real cool. I actually have the cold water coming in at the bottom and then coming towards the top. So we're distilling off some of the mixture now. I don't know how long it's going to take. The temperature has gotten up all the way to right around 95, and when it hits 110, that's about when we'll stop this. Then we should have boiled out all of the water. So remember, the water is coming off as a product of the reactions. As we boil that water out, we'll be forming the enamine, and then we'll continue on with the rest of the experiment. So I don't know if you can see this. There's a cloudy mixture, and if you go underneath it, you can see a little bit of water that's directly at the bottom. Now, this azeotrope consists of about 80 or so percent toluene and 20% water. I'm expecting, I think, about 1 mil or less of water out of this reaction. And so I may have it here, but I don't think so. I'll recheck my calculation and let you know. So I think this is just about done. If I look at the temperature now, my little marker, right? It's right at 109, 110. It's slowed down a little bit, but you can keep distilling toluene off this. And actually, we're going to do that after the end of a 1 week reaction. What the mixture looks like now, a little bit yellow, just like this. Yeah, it looks pretty normal. So basically what I'm doing right now is I'm really just boiling toluene off. And I have a feeling most of the water has been distilled off. I should have roughly 1/3 of a mil of water at the bottom of this reaction vessel. So I'm going to actually try to separate that out, but I'll do that after I finish the rest of the experiment. So I have my conical vial. I'm going to mix up my toluene acetic anhydride mixture. Toluene, I need 2 mils, so I just used the old pipette I had from before. The exact amount doesn't matter. You end up distilling this, if you read down in the procedure, exact amount's not important for that. I just have my pipettes over here, by the way, because you distill that out. Oops. And then I'm putting my acetic anhydride on there. That open. And based on my calculations, I need about 2 mils. I modified, if you remember, I modified this procedure just a little bit. So I'm going to add 2 mils of acetic anhydride. Did not do what I wanted it to. There we go. There's 1. That's 2. Now that I have that mixed up, or I will mix it up, I will add that to my reaction. So this is what it looks like right now. It's still a little warm, but it's not hot anymore. And now I'll go ahead and add that mixture. I'm just going to use this pipette to mix it together. Should be just about 4 mils in this. Yep. There we go. You notice a deeper color that it has right now. You'll see that in the final product. It'll have a real dark color to it. All right, so that's that. Now, this part of the experiment takes a few days. I usually give it a week, but it takes a few days for this reaction to finally complete. The acylation is just slow. I really haven't thought that hard about why that is, but that may be something we have to think about as we prepare a report, okay?